Good evening once again. My name remains Dr. Nayo. Will be taking you on this course, CSE 811. That is Embedded Systems or ES. This course is 3 credit units and it is compulsory for every student or every master student. Okay, so we have the course outline. This course outline is going to guide all our discussions. We have to do justice to this course using the course outline. Knowing that in this course, we'll be taking the lecture. There will be an assignment or continuous assessment. The continuous assessment may be grouped or may be undertaken individual. However, since the number of you are few, I think it's better there is an idea for us to, or everyone will undertake each assignment that will be done at your convenience. And the earlier we start it, the better. I always like to give my assignments at the first or second lecture of the, at the first or second meeting of or contact. It is important so that you begin to prepare yourself on time. I don't like any fire brigade approach. I don't like in a rush, working in a pressure. I want my students to take time, follow the pace, understand what you're supposed to do. If you have any assignment, the earlier you start the assignment, the better. You take time, do the assignment, submit, then we'll move on. I may not administer tests. I prefer giving an assignment and I will monitor it. And let me tell you, failure to do the assignment, you already calling 50% chance of failing the course. That is it. So it's as good as writing the exam because the CA is 30 marks, exam is 70 marks. But you can easily get 30 over 30 or very good mark in the assignment than the exam. So in the assignment, you are sure that you are going to have a very effective grade than the exam because exam, you will be writing under tension. You wouldn't know what may happen at the very day the exam will be taken. So, but in the assignment, you take it, you use your pace at home, work on it, and you're good to go. So I encourage you, whenever the assignment is given, make out your time, try as much as you can before other workload will begin to choke you to do the assignment as much as you can. So I will share the guide on how the assignment is going to be or the nature of the assignment as time goes on, either today or in our next class. Okay, we move on regardless. In the course outline, we'll be looking at the introduction, what expert system actually expresses. We'll look at some special needs, look at the types of processors, that have been utilized, and then other peculiarities involve embedded system. Different processors, 8-bit, 8085 type, 8051, PIC 18, FSXX bit processors, and the rest of them. Then, as we move on, we will look at operating system for for embedded systems, where we look at real-time operating system issues, input or output programming such as synchronization, transfer rate, and latency, full I/O issues, interrupt-driven I/O issues, and the rest of them. So we move further to look at the concurrency control. Then we'll look at scheduling in expert system. We also look at the memory management in embedded system. So finally, we'll look at the boot up and system initialization using the processor that have been deployed in embedded system. Then for the material, I've shared it in your platform. So all the files I share in your platform were materials. Is a main focus. All we are going to be discussing is centered on those materials because I just x-ray them by bringing them up, summarize them a bit. So we'll use those textbooks or ebooks, including my notes. So because this is a master level. At the master level, you are expected to understand every bit. Every bit is no longer normal way to just to read and pass or just pass. No. During our undergraduate level, we are more conscious of passing the exam. We will be more exam focused. But at the master level, you are expected to master everything that comes your way, so that by the time you award the certificate, you can now boast that yes, I master this, I master that. So you should be able to be an authority to undertake everything that comes your way. It is now you have to, during the undergraduate, you make more use of your IQ, intelligent quotient. But in your at master level, you begin to match your IQ with EQ. So you have to make use of make more use of your EQ, emotional quotient, than instead of IQ, intelligent quotient. So, or you try to marry the two of them, IQ and EQ, but EQ play a very sensitive role here. All right. Moving on, we'll look at the introduction to embedded system or introduction of embedded system. Introduction to embedded system. So whichever one the phrase you actually put it. But the idea here is we want to look at what is embedded and what is system. There are two keywords, embedded and we have system. So when we understand what is called embedded, then we will now look at what is system. We'll now merge them together. So in a normal English setting or English language, if I may ask, when you hear a word embedded, what do you think it means? let's not connect it to computer, just a normal grammatical usage. Embedded. Maybe you want to speak a grammar, it's embedded. Or somebody mentioned about embedded, maybe on the normal English spoken word. So what will come to your mind?
Something inside another thing.
Okay. Something that is
Like,
under something.
yes.
Maybe normally one can use the expression say, check the money, it is embedded inside your pocket. So, and when we talk about system, let's connect it through the idea of, I believe most of us did biology or biology. The biology we talk about cell, we talk about organs, we talk about systems. I hope we can recall, because as I said earlier, at the master level, you are expected to have firm understanding of whatever thing that you are being taught. And doing that, you try to connect whatever thing you're reasoning into a real life scenarios. I'll try as much as I can to use some real life scenarios to connect you to what we are doing. So that if you forget the grammar, you'll be able to remember things around you. So that even if you ask, or someone asks you, what is embedded or what is the embedded system, you can use your, even if you without reading it, you should be able to use your EQ to begin to rationalize the meaning of the word, break it down, embedded, and join them with system. When you know these things, cover that during the exam, even if you ask or anywhere, you don't need to crack your brain. You don't need to cram it before you be able to remember it, because nobody is expecting you to write verbatim in your exam. Just pick the keyword. You can use your own knowledge to write it. It's acceptable. It's acceptable. It's not like undergraduate. So now we have to reflect our mind for our biology. We are told or taught that cell is the smallest unit of life, in which every other life begat or begotten. That is the smallest unit of life. Then we now have organ. Organ is, combinations of different cells that bring together to form organs. And that's why we have different organs, like eyes, your heart, your brain, your body. These are different organs in the body system. Then we now say a system is a combination of organs put together. Collectively, you call it a system. That is to say, a system is a complete set. Is a complete set put together. Assemble them together. Once you assemble different components, different parts, bring them together, become a system. That's why sometimes you hear about software system. You see, when you talk about software system, you're talking about a complete, workable and functional software. When you talk about hardware system, you're talking about a complete part, assembled hardware components, bring them together. When you talk about school system, we are talking about a complete hub of academic units or processes put together. We call it what? Educational system. Well, sometimes you will hear university system. When you talk about when there is a system, see it as we are looking about all the network, all the things, parts of the university, including both academics, non-academics, works, and the rest of them. Put them together, we call it, say, university system. Now, let's come back home. When you hear about embedded system, you see, you hear that we're talking about all the components, all the parts put together. Once all of them are put together, it's called embedded because of the system. With all the ones that have been put together or put under, bring them together, we now refer it as what? Embedded system. In other words, we see that embedded system is an integrated system or combinational integrated system that is formed as a combination of computer hardware and then software. All of them are put together to perform a specific function. Embedded system. Bring different systems, bring them together. As I said before, we have a hardware system, we have a software system. So when you bring the hardware component, bring the software component, you combine them together to solve a specific functions. Underneath, we can call it or refer it to as embedded system. We then further try to say that this embedded system can work with or without human intervention. This embedded system, when fully developed, it can function or work with your own input or without or less input. Are we following?
We are with you, doctor.
Okay, because I always like my class to be interactive. I always say this each time I engage students for lectures. I have one philosophy. This philosophy is very simple. Everyone is a teacher and everyone is a learner. Everyone is a learner and everyone is what is a teacher. Or everyone is a teacher and everyone is what is a learner. So it is good that you understand the foundations of what we are in. We want to understand what really embedded is. I'm taking time to explain so that you don't need to cram it to explain to someone. Or even if you are asked, you should be able to explain it. It's involved different systems. Someone may say, what is other systems? We talk about hardware. Who can make sure that it is one or two hardware components we know? Can someone mention 2 or 3 parts or hardware components?
Keyboard, monitor.
We have the CPU itself.
Okay.
The monitor.
Okay.
Mm-hmm.
Okay. Then can someone mention some examples of software system or components?
We have the operating system software, and we also have the application software.
Okay.
Also, utility software.
Okay. So this is to say that when both the hardware meet the software, bring them together underneath is we refer it to as embedded system. All right. So, and remember that when all these systems are integrated together, it can function as a smart system. There may be an intelligent because some hardware components like sensors are all hardware components. When some of these sensors are put together, sometimes it functions even without your own input. So, having noted this, let's look at the main component of expert system, which is the shortcut is ES. When I talk about ES, you are talking about expert, embedded system. Sometimes, I recently thought about expert system. That is why sometimes when I see ES, I always almost call it expert system. But both of them share almost the same code, but this one is embedded system. So in all, we have three specific components of expert system. Number one is software. Number two is hardware. And the third one is firmware. Firmware. The most common one we know is about software and hardware. But we have firmware. In fact, expert system mostly use firmware because firmware is application that is developed to access or control the hardware or being embedded in the hardware. For the hardware to function, it needs what? A firmware to function. So as we move further, you understand better about that firmware. So now, let's look at the examples of expert system. Let's discuss this. It may look funny. Somebody somebody asked you to explain digital watch, or somebody asked you to explain washing machine, or somebody asked you to explain television. It may look funny, but in details, if I want to ask, even say in the exam, as you're looking at it like this, I may ask you, what is the mechanism that behind digital watch or washing machine? What are the mechanisms that navigate washing machine? Or when it comes to cameras, how does expert system drive camera operations? You see how the question is now being twisted. In digital watches, washing machines, and so many of them, for instance now, in the washing machine, how do expert system influence washing machine? It influences washing machine in the sense that it can enable you perform different operations. When you use washing machine, you can set it in different temperature or use the knob for different functions. One knob or button can perform more than one operations. If you look at, maybe if you want to dry, if you want it to do this, if it's a light cloth, you can use the same knob or button to set them. If you look at, if you go to your kitchen, you see table burner. You see, under table burner, we have maybe some is just only one button or knob. You can use it to turn it on. You can use it to turn it off. Have you seen how one button is performing two operations? The same button you use to turn it on, the same button you can use to turn it off. A lot of impact or functions of expert system cannot be overemphasized in different areas like this. So let's look at now the real application areas of expert system. Now, if you look at home appliances, somebody can say, how can expert system be applied in home appliances? Because what we are saying that there is a system that is embedded, that is hidden or integrated inside, that enables you to perform a specific functions. In home appliances, just as I mentioned about burner, I mentioned about washing machine. Some people have a smart door. In some hotels, when you visit them, they have a smart doors. Some of the hotels, once you are coming, it automatically was open. It means that there is a sensor sensing that there is a human being coming. And this sensor will not have that sign or feelings, the door will do what? Open. All the smart doors. There is another area, some use a smart card to open their door. They is being configured or integrated with maybe using different chips. Some of our home appliances uses voice to operate. There was an application developed to manage your home appliances. Maybe if you come to the door, if you don't want to knock, just door open. They train their voice. Just the door open, the door will do what? Open. Some use fingerprint to open their doors, just as we use it to open our phone. Are we following?
Yes, sir.
Some use facial recognitions to open their door. I mean, door. All these devices are situated in our individual house. So all these are sensors, different sensors programmed inside that system through the help of firmware. Then, if you look at the area of transportation, the impact or application of expert system cannot be overemphasized. Take, for example, If you are using your car have a sensor. These are embedded. If you want to approach an object, it will tell you. Some of them have object recognition. If you want to fall inside gutter, the system should be able to help you. This system want to. You're already approaching beyond the lane. This Google Map in your own car is being integrated. In your phone is integrated. These are aided with embedded system. They are being embedded, they are being inputted, coded inside it. Is it healthcare? Several ways where areas in healthcare that embedded systems are playing better roles. If you have visited ICU, intensive care unit in a hospital, you will see a tremendous impact of expert system. If you look at some of the temperature, the accelerators they are using there, or accelerometers, the gyroscopes, the impulse sensors, different sensors that the machine integrated with. Maybe somebody is needed some air, or what is it called? Maybe oxygen. Someone needs an oxygen. If you go to where someone that they fix an oxygen, you see how there is already the machine positioned in the intensive care unit. And that is why those who work in the hospital, especially the ICU unit, they are most skilled staffs. They are skilled nurses that work there. I have a friend for a certain time. Each time maybe I visit her in the hospital. Anytime she's on night shift, they doesn't sleep. Especially when they have some critical case. Their eye will be fixed on that machine, ICU machine. They ensure that they regulate the temperature, the body, blood, the BP of that patient. So all these things are facilitated with the help of what? Expert system. All of them were made possible, effectively developed through expert system. So many areas of applications in the healthcare. Expert system will also help you for security of patient data. Expert system will help you for protect some of the patient records in the hospital. So business sectors and offices. So many, in fact, some of this artificial intelligence are here, function well through the help of what? Embedded system. Because all these systems are developed, you put them, maybe you develop a software and then you package it. But for that software to function, there will be some hardware components like IoTs, Internet of Things, IOMT, Internet of Medical Things. All of them are driven by embedded system. We are now optimizing our devices. Before you see a very big computer, or even laptop that is probably 15 inches screen. So at the point it was reduced to 14 inches. And you can even see up to 5 inches. There are some very, small laptop. Some they call it notebook. So we can twist it, you can bend it, you can turn it, you can rotate it. These are what we are talking about. Expert system helps you to achieve them. So defense sectors, aerospace, agriculture, so many impacts. Because we're talking about agriculture, you are talking about smart farming, you are talking about area man, like using drones technologies for farming, for irrigation, and the rest of them. So, and it is based on these areas, I would like us to be reflecting our minds. We may pick some topics related to some of these areas, and then we'll have to research to see how far, what are the roles or the impacts of expert system play in some of these fields. I will get some, maybe try to look for emerging a new trend part of these application areas where embedded system can be investigated. We can do an investigation how expert system, some of the roles it plays in some of these application areas. And that is where my assignment will be drawing from. It will be good for us to look at, to investigate expert system in some of these areas. It's very, very important. Excuse me. Okay. Now we'll look at, as we were discussing, some of the real-life embedded system applications. So there are many things with embedded system that have been integrated in IoT. Also machine-to-machine devices. Exceptionally versatile and adaptable, embedded system can be found in all smart devices today, as I was explaining to you before. Almost all the smart devices, expert systems are found in them, because those devices uses chips. Those devices, some of them uses transistors. Some of them use conductors. So that is why they say that any smart systems or devices, embedded system is found in them. It is difficult to find a single portion of modern life that does not involve this technology. Very, very difficult. Very, very difficult to locate any technology that does not involve expert system. So, looking for that, we will see central heating system. Even the heater we use, the heater, it is because you ask yourself, how does it get heat? Why is it heated? When you pour water and you plug it, before you know it, the water will boil. That is why if you check the heater that condense where the water drops, and what is funny about some of these things is that you use the regulator to control the same heater. Do you need cold water? Do you need hot water? It is a sensor that control these two specific functions. You also wonder when you see electric kettle. There is one. You know that we have some smart electric kettle. Are you aware of that? There is smart electric kettle. I just finished. Okay, this one we have a electric kettle that when you put water and then plug to boil water, let's assume that maybe you plug it to heat water and or to boil water. You step out. What the electric kettle does that once the thing is boiled to a normal degree, centigrade of that water, it will automatically off itself. That water makes it smart. Once it boils to the normal degree for water to boil, it will automatically turn off. The first time I used it, I shouted, I said, wow. I was rushing out because I plugged it, I was busy, my system, shifted my attention. I didn't even remember that I actually plugged boiling water. Before I could check there, it has already automatically off or turned off. And okay, today I did one experiment. The water boiled to a boiling point. Immediately it hits the boiling point. It's off. So when I came in, I tried to on the button to put it on. Probably maybe the water must have reduced the maybe I felt maybe it's getting cold. I put it a button, the thing automatically off. I put it automatically off. Then I now pour the water inside the cup. I saw that it has reached at a maximum boiling point. That is what they call smart system or smart heating, central heating, and some of them are central, some of them are not central, are decentralized. Some of them are just a single device, like the electric kettle I'm talking about. We have GPS systems, geographical positioning systems. We have fitness trackers. Those who want to track their fitness, maybe if you go to some of the places that are probably do a fitness training, they want to massaging centers, all these healthcare centers. You see different devices. You use it for exercise, So if you are walking, based on some of the sensors there, maybe if you are walking, you will not use the one they call that is enabled with gyroscope. And if you want to fall, it will be able to tell you want to fall. Then if you are maybe like that one gyroscope take the step count, then we have accelerometer, check both the angular position of the system. So all these things are some of the things that experts embedded system helps to facilitate. Medical devices, we'll discuss about that. Automotive systems, bioprinters for 3D modeling of human organs, ATM machines. Do you see that ATM machines automated teller machines. It is also if you want to withdraw money in ATM, just try to shift your face from the camera. It will it cannot make transaction. It is that it sees your card or you push your card out. It can never complete that transaction. You can try it. Each time maybe you want to make withdrawal in ATM, turn your face or shift from a bit, you can never carry out that transaction. These are the help of embedded system in terms of to maintain the high level of security. That system is trying to and each time you withdraw money in the ATM, it automatically capture your face. And that is why if you take your face out from that camera, you cannot make transaction because these are security features that was enabled. So that in case if there is any theft or scandal, they will be able to track it from their systems where all these images are being captured. So factory robots, electric vehicles, charging stations, interactive kiosks. So all these things, it has actually, some of these machine-to-machines, M2M devices, embedded systems have actually played a very, very significant roles. Okay. Now, let's quickly look at important characteristics of an expert system. Important characteristics of expert system. We have so many importance of this system. Number one, it performs specific tasks. Say for instance, specific functions or tasks. Maybe you only want that camera to capture an image, or you want it, maybe you have a smart door and somebody is coming, let the door open. So there must be a specific task or functions that the system should be able to perform. Why are we talking about the expert system? Why is it so important? Why is it essential to discuss? Why are we learning expert system? We are learning because it has its low cost. The price of expert system is not so expensive. It's not so expensive in nature. That is why you should go for expert system development. So, in terms of time space peak, it performs a task within a certain time frame. Of course, any command issued, it will execute it based on what you have to code. It has low power. Just a minimal power it can operate or work with. You don't need enough power or energy to use a system that is enabled with the expert system. Remember that other place with also cameras, phones, all these things, even our phones have or it has been facilitated by the help of expert system. And that is why you can have small phone performing a very good task. The phone or the efficiency of the phone It's not really determined based on the size. The performance of the phone is not determined by the size, it's determined by the features. It is determined by the different components that was integrated. So it also helps in high efficiency. So the efficiency is always high. It helps to minimize users' interface. This system requires less user interface and it is very easy to use. It minimizes user interface. For instance, now, in your washing machine, just only the on top, you know, you don't need to have a very large interface for it to work. Digital camera can also work. So even in your car, you have some enabled GPS. It doesn't require much interface for it to work. You can use it as well. Less human intervention requires no or less human intervention. It has high stable in terms of maintenance stability. It is reliable. And when you want to use the microprocessor or microcontrollers, the use of microprocessor or microcontrollers to design and use limited memory. You don't even need enough much memory. The manufacturer, we're looking at about the most of expert systems are compact and affordable to manufacture. They are based on the size and low complexity of the hardware. It's just that in the lab, a lot of the embedded system components, most of them are not really under usage. On the normal, we need to perform one experiment, with some of the technologies to actually X-ray. I will discuss with the person in charge in the AI lab, the technologies, if some of the devices or components that will be used to explore this applicability of expert system. I'll check the lab and see how possible we can probably have a hands-on practice or look on the expert about the embedded system. However, knowing well that we say that almost, don't forget this, almost of our technologies, these modern life technologies, they hardly exist without embedded system. That embedded system can be found in all smart devices. One is smart device, knowing well that there is presence of expert system, sort of embedded system. Slip of tongue. So always know that there is embedded system have been applied in those devices as far as the smart device. Okay, so I think that is where we'll draw the curtain for today. Maybe in our next class we'll now take the block structure diagram of embedded system. So at this juncture, if you have any questions or concern, please feel free to ask. We just try to introduce the course, know what you expect or what is expected in the course, understand what the embedded system is, what are the application areas, how can you feel or interpret or explore the functions or the presence of expert system in some of the smart devices. So thank you. If you have any concern or question, please feel free to discuss or ask. So I'm waiting for your question, contributions, and all that if there is any.